Welcome to the Decoding Innovation podcast series, brought to you by the EY Nottingham Spurk Innovation Hub, where we explore the innovative technologies, business models, and ideas that are shaping the future of industries. During each episode, we meet with stakeholders at the cutting edge to discuss innovations in their space, challenges they need to overcome, and their outlook on the future.
Welcome to the Decoding Innovation podcast. I'm your host, Brent Dersch, and I'm coming to you from the EY Nottingham Spurk Innovation Hub in Cleveland. I am joined today by Hemali Vyas, who is a project support manager at the NASA Jet Propulsion Laboratory. Hemali, welcome to the show.
Thank you, Brent. I'm looking forward to our conversations.
Excellent. Well, let's get started. Before we get into the line of questions today, let's talk a little bit about your background. Could you tell us a little bit about your career journey so far?
It's been quite a bit of a long journey, but it has been interesting for me. Currently, I'm at NASA Jet Propulsion Laboratory, Pasadena, California. And I actually did start my journey from NASA JPL as a student, as a software engineer for the Deep Space Network. I got my bachelor's and master's in electrical engineering, and then I moved on to Northrop Grumman for a little while, and then came back again to JPL, working on a concept called Mars Network, where at one point we wanted to do a relay orbiters, just like Starlink that we have over here, but at that time, 6 satellites to provide more assets over there for communications. And then again, left JPL to go to a startup called Surf Technologies that put GPS on cell phones, that opened up location-based services for us. Went to L3 for GPS modernization, which was different signals to get better performance on GPS. And then since then, I've been back at JPL doing a lot of different things, from GPS signals for radio occultation studies, science instruments, telescopes, and now I'm at the project support office, and that is an institutional organization that goes across all the projects, all the spaceflight projects, to support them for mission success.
Excellent. So could you expand a little bit just on what kind of projects you and your team have been working on at NASA?
Okay. We've worked on, if I go through everything from Deep Space Network, which tracks everything all the way to Voyager, which is out of our solar system. It takes about 18 or 20 hours just for the signal to get there to talk to it. So I worked on that for the software. I worked on what used to be, what is Artemis now, but was a constellation project in 2008 timeframe, which is going back to the moon and Mars. The revamp of the Artemis program that we have now. I worked on some science instrument for a SphereX mission that'll launch soon, which is a cosmology mission. So it was all about the science instruments and detectors and stuff. On the Surf side, I was the project manager and also the systems engineer for the GPS chipset to make sure that we delivered on time and for the market, and we did succeed on that. So basically, I've gone through a lot of different project problems, and I'm not in a one-dimensional lane. I like applying my skill set to different projects to open up the curiosity that I have in learning about different things. At one point, I also assisted in the strategic plan for Jet Propulsion Laboratory in terms of what do we look at for the future. And then on some aspects, given in the project support office, we also do a lot of flight projects and the infrastructure support, so IT-related tasks that helps the flight projects. I've also worked on that.
Fantastic. So let's maybe take some elements of your career journey step by step and talk a little bit about each one of them, because you have a very unique perspective from having spent time in the private sector, the public sector, helped launch startups. You've seen innovation from a variety of different angles. So maybe first, could you talk about some of the innovation challenges that you saw during your time in the private sector, and how some of those challenges were overcome or addressed.
On the private sector, there are two different roles in the private sector, I would say, that I'm going to focus on. One is working at a startup, and one is creating at a startup. Working at a startup, obviously, there's slightly defined role of what your role should be, but there's also a boundaryless ability to work across different segments because resources are limited. Because it was sort of an established, I think there was 150 people when I joined the startup. There was always a concern about will there be enough funding to take it to the next level, and also the competition, right? So there was always a concern that would that be ever a problem? And as a team, we succeeded over there. It actually went an IPO at one point, and then got sold out to different pieces. In terms of the private sector startup on our domain, I think it was initially when we started All Logistics International, it was self-funded. And then that was a time when 2008 financial crisis hit. So what we were trying to do was bring visibility to supply chain networks, because supply chain is such a manual process at individual nodes, whether you take warehouse or transportation or any kind of customs or everything. So we're trying to add like visibility so that we can have efficient approach to supply chain. It was a time where people didn't understand what supply chain meant. This is pre-COVID. Technology wasn't there, computing wasn't there, cloud wasn't there. And then people are still used to holding on to their data. So I think we succeeded, but not to the level as much. The second startup that we had, that we started about 5 years ago, I want to say 5 or 6 years ago, was about recognizing that warehouses are not fully utilized. 30% of its resources are not utilized. Their planning is very manual. So what happens in peak season times, their planning kind of peaks up. They have to plan 6 months ahead of how much they have to fill up. And then the rest of the season, they're like low. So on an average, it was 35% of resources that were not used. It was a little bit more near real-time planning versus, planning ahead of time for the warehouses. And also for small customers, it gives them a chance to go on a platform to find warehouse for themselves.
Right. So expanding a little bit on the warehousing startup, can you talk a little bit about both how the idea was conceived and maybe how that idea evolved during throughout the course of that startup journey?
The idea was evolved. So, I have some exposure to supply chain because my spouse is in supply chain industry, and I bring the technology perspective to it. So we had been discussing about this problem for a while, and now that technology is quite a bit ripe in so many different areas, we felt like it was the right time to address it. So we worked with a private equity person and kind of built that up. We actually went through the typical startup phase that we have right now with angel funding, family and friends funding. Created an actual MVP, which is a minimum viable product, to kind of show our potential clients and investors of what this means and how does this take further. And so we kind of built that platform, we got the funding, and then we moved forward. The learning lesson that we got out of it, this is going to be click and move forward. It wasn't as easy as that because, warehouses are owned by companies and they have their clients and their products. And so they had to protect, anything coming into their warehouse. There was the insurance aspects of it. There was a legality aspect of it. And it did require a little bit more handshake to work with the clients one-on-one to make that happen.
Got it. And could you talk a little bit about how the business model was constructed around this startup, and if that business model sort of evolved over time as well?
The business model, so it took a little research. I had spent some time understanding, being in California, understanding the California market. I also took some time to understand the development that was going on to build more warehouse spaces. It seemed like there was a need for warehouse spaces. And so there was a lot of state documents that I went through in terms of the potential development that was going on. So it was kind of trying to take advantage of the resource that was underutilized versus trying to build new infrastructure, which is a lot of CapEx also, to come up with this model and try to build that and take it forward.
So as you had made the shift, from NASA and come into the, kind of come into the startup world, what sort of a mindset shift did you have to go through as you went through that transition?
Okay. So I actually did not make a shift from NASA. I was doing both at the same time.
Excellent.
Yeah. So the shift and I think part of it is my previous, NASA DoD experience combined with my startup experience at Serve allowed me to integrate that thought process for this particular scenario. I felt like I learned a lot from a NASA's perspective, dealing with complex problems in a systems way of thinking, came to the picture of it, and working at the startup, the boundaryless approach where there's less bureaucracy, you can kind of solve any problem. I think that together helped me over here a lot more because there was nothing that needed permission as much as you just kind of move forward and start solving the problem wherever the need was at.
You mentioned systems thinking. Could you expand a little bit on what systems thinking is and how you've made it part of your approach to innovation over the years?
So systems thinking is something that I have learned and grown through mostly my NASA JPL experience, but it's also a DoD aerospace defense. Again, I've applied most of my experiences at NASA JPL. And systems thinking is basically, you take any problem and you have an ability to think about it from top down and bottoms up approach. Or in another way of thinking it strategically with tactical mindset, if that makes sense. The intent is that you want the system to operate efficiently. But before you get to that systems, you're going to have to build up its components. And so you want to have enough understanding about those components, how they come together so that the system operates, and then dive down into a component that needs attention rather than worrying about all the details of all the components. So the ability to switch back and forth to address the problem systematically is what I would say is systems thinking. Along with that, understanding the risk and mitigation paths to address it, because nothing is risk-free, right? So you got to really give, and that experience comes from working on spacecrafts and space technologies, because you got to think about a lot of risks that may come up and have mitigation plans for it. So I think solving top-down, bottoms-up, along with risk mitigation is kind of what I would say is systems thinking.
And is there an example that you could share with us, a story you could walk us through of how systems thinking was applied to solve a big, hairy challenge?
I did work on the SphereX Step 1 proposal. And I was the instrument systems engineer at that time for the mid-wave infrared instrument. And that required the understanding of the science requirements and how does that translate into the instrument requirements and building that. At the same time, identifying the risks. For example, one of the risks could have been the detectors that we were using. And the detectors, will they come on time, for example, right? And how do you mitigate that? And if they come on time, will they meet performance? How do you mitigate that? So it's kind of working through those little step components at the same time, trying to map to what are the science performance requirements. That is kind of one way. If I look at it from a GPS perspective that we're working at, I was trying to make sure that, is the performance of this GPS, is it going to take like 5 minutes for it to compute my location, which is not going to be acceptable. So how do they call it time to first fix, TTFF. How do I reduce that with the low power? Because you can't take a GPS chip, take up the full power of your cell phone, destroys the purpose of it, right? So I think it's that kind of a thinking where you're diving into the simulations, you're diving into the testing to make sure it's working. At the same time, you're keeping your customer mindset open, saying, okay, I need this to be operating in a customer scenario and not take it over. Just, if you're just a GPS engineer, for example, it'd be like, oh my God, I'm just going to focus on that without giving a customer mindset. But if you think in terms of system, in terms of market, in terms of sponsors and market, I'm using it very carefully because on the NASA side, market is not a very well recognized term, but it is needed in the sense that your clients, your sponsors, or whatever, you got to think in those terms to be able to succeed. It's not just the development.
Great. So we've talked a little bit about what you were able to bring from the world of NASA from a thought process standpoint around systems thinking into the world of startups. Let's flip that around a little bit and talk about, are there lessons you've learned through the world of working in the startup world that you've been able to take back to and integrate into your work at NASA?
Definitely, I think the boundaryless thought process, the problem needs to be solved, and how do you deal with the boundary scenario? Which as the organizations grow, they need a little more structure for efficiency and so on. It creates boundaries, and so how do you address those boundaryless concepts in a little bit more larger organization? And so, yeah, I've tried to apply that. It takes a little effort. It takes a little mind of consensus and collaboration. And as an example, I was given a task a couple of years ago, where, in today's time, IT is a baseline infrastructure where every organization operates from. So no matter what your purpose is, whether it's space or medicine or whatever, we all need IT infrastructure. And so I was given a task to work with the IT team to help provide efficient methodologies to support the flight projects, because a lot of times flight projects come in last minute saying, I need this IT support, or blah, whatever their needs are. And suddenly it becomes a huge task for the IT team, becomes more expensive, could have a schedule impact. So the intent was to see, can we develop an approach to an infrastructure IT for flight projects, so that the IT needs are met in a timely and cost-effective way. And in that scenario, we had defined the problem scenario. I worked closely with the IT team. We defined the scenario, worked with every project, and said, here's the problem, and here's how we could if you can assist us and give us some prediction of what do you need through different life cycle phases of your project, we can try to integrate that with what other projects need and see if you could take a bulk buy approach to reduce costs and to reduce schedule. And something like that is a little hard to do when you have IT and then you have flight projects, right? Because I think culturally they are not used to it from the past. There was no such thing as IT 20, 30 years ago. You just had computer needs. And so there's a mindset change that you have to help merge together from an IT perspective, because on the IT side, it's like, why don't they get us? It's just trying to help each other understand. And so we worked very closely together, and we identified a solution. We not only talked to quite a few projects, got their feedback, integrated their feedback, came up with an approach and process, and then we actually went to all the management stakeholders to get their consensus, got it approved, and created a plan and approach where as of right now, about 8 or 9 of our projects are implementing it.
So having been in, kind of that boundaryless, startup world, and then, thinking about the environment that you're in at NASA today, what are some of the inherent advantages you see that, kind of a large agency like NASA has when it comes to investing in and driving innovative efforts?
So I want to clarify that a little bit in the sense of innovative efforts. I think when it comes to innovation, I think the innovation at NASA JPL is at an exponential level. So I'm talking about the space flight innovation, right? There's so much of research, so much of technology development that goes on. When it comes to innovation of what's happening in the industry for enterprises, that adaptation requires a little bit of blending the two cultures together, because you have IT with what's happening in the industry, and you have space flight of their innovation. And so that requires really merging the boundaries and helping each other see to say, hey, we're all the parts of the same problem. We're trying to solve a bigger purpose, and having solved the enterprise solution will actually help the flight project success. And having understood the flight project will actually help the ITs to understand how to support the needs. So if I go back to, again, NASA JPL, I think they are wonderful in terms of space-related innovation. I think there's a recognition and there's an effort going on of how to improve the enterprise transformation, because we all kind of, I think every organization, whether NASA or not, are dealing with this enterprise transformation because the technology took a jump. We have cheaper computing, cheaper processing, cheaper storage, and now AI ML. So everyone's trying to figure out how to apply that.
So on the topic of, you brought up AI and machine learning. Can you talk a little bit about how you've seen that playing out within NASA and within the jet propulsion programs?
So I don't know much on the NASA end, but on the JPL end, just last summer, I think like every other organization, we're trying to figure out how to use it. I think there was a pilot project that our co-organization did with a student intern in terms of how do you apply. We have a lot of documentations that we call rules, where it defines some of the specificity of how a flight project should execute. What are some of the design principles that we should not forget about? Because again, you're going in space, there are unknown factors. You got to think through all of that. So there's a lot of that documentation that projects have to assess their projects and apply and comply by. This effort was trying to take AI ML kind of mindset, especially like with ChatGPT rising, right? To see how we could feed this documentation and apply towards the stuff. And it was a pilot project. I think there is a huge case to apply to it, but there's also a fundamental background of, any AI ML model needs learning. So there's a learning effort that needs to be put in. There's a computing that is going to be needed. There is a protection of, cybersecurity. You can't just go to an external chat GPT. So you got to figure out those factors internally because of the cyber threats. So there are all these things that are coming into the play. So in terms of applicability, yes, there is. In terms of the implementation of that applicability, it would take some time.
So to pivot just a little bit, you're the chair of the Space Economy Committee at the AIAA, correct?
Yes.
So I want to talk a little bit about this. We spend a lot of time working with our clients at the Innovation Hub around their challenges of commercializing innovation on Earth, right? So I'm excited to talk about space commercialization, right? And what that means. So to start out, can you talk a little bit, conceptually around the challenges you're dealing with when we talk about space commercialization?
Okay, so first of all, I want to say when we think of space, we think of this one big black cosmos when we look up. When we think about space economy, it took, I was trying to dive into that problem, what that means. And then I realized, I think when we talk about space economy, we cannot just talk about this big black thing that's out there. I think there's a need for it to be categorized a little bit in terms of the nodes. I call it nodes of space economy. So anything around Earth, whether it's LEO, which is low Earth orbit, or GEO, which is geostationary Earth orbit, right? Anything around Earth, lunar, cislunar, Mars, and beyond, right? To me, those are individual nodes, and I think we should be thinking about space economy in terms of those nodes, because the investment, the risk, the maturity, the supply chain, all of those nodes differ depending, where you're applying it. So if you take at the any space economy that is Earth related, we already see the growth in there. At the same time, there are three different components for space economy. If you just focus on the Earth side of it, and that model applies to wherever, but I'm going to focus on Earth. You see the upstream, which is the manufacturing side of it, where you're manufacturing your satellites and your payloads and any support equipment, test equipments that go with it. Then you see the midstream, which is your launch vehicle areas, right? Anything to launch it and any ground systems to support it. And then you see your downstream, which is your space data products and how do you use that. And I think it's a downstream, they all have a component towards economy. The downstream data is where there's a lot of growth happening, including with the upstream where there's a lot more satellites being launched now. So I think, GPS is a perfect example of the downstream data of space economy. It just opened up. Once we were able to compute GPS on our cell phones or on our iWatches, it just opened up the market for location-based services. Same thing with Starlink, as we increase our network globally, you're going to see a lot more business and personal applications where people want to use that in remote areas. Even as just throwing out as an example, there's a visionary not there, but you could do anything from customizing your fashion across somewhere in Italy or India or whatever, because now you can talk to the person and maybe there's a 3D printing approach of manufacturing some samples and getting it sent. It's the ways of pushing your edge. Whether it's there or not right now, no, but these are the opportunities that could open up. Supply chain is another one, with communications and imaging, that it could open up the industry even more with more efficient methods. Climate change is another one where the NASA Earth Science data will open up industries where insurance industries and real estate industries are interested in the space data products to figure out that. So that's the Earth economy. When you start coming to lunar, cislunar, you start seeing signs. You had two commercial companies that made an attempt to land on the moon. There were some failures, but that doesn't mean they won't come back, right? And so there's a support from NASA on that, and there's also support from private industries funding it. So there is signs showing up on lunar, cislunar. There's a strategic reason. There's geopolitical reasons. So I think there might be a push to get there at some point. Maturity of it is a little low. There is risk associated with it. And then Mars is, to me, a little bit further off in terms. And then you talk about space industries, space tourism. I would say it's a little low maturity. There's a lot that needs to happen there. But you know what? If private space station comes in, maybe medical research on private space station could be a big boom. Agriculture research could be a big boom because you can learn whatever you do and bring that down. So there are all these different things. But again, I think it's important to think in terms of nodes and frameworks and not just bundle everything up into one big black space. So one other thing that I wanted to add is we're now in the phase with cheap computing, cheap processing, cloud, AI, ML, and space, and low cost of launch. And so a lot of pieces are coming together where space economy is starting to grow. But I wanted to clarify that when we think in terms of space economy, that we understand it's not just about launching and putting things in space. I think a lot of growth comes down to the downstream economy. So companies should be thinking about either how do I use this for my efficiency and my better growth, or how do I create new companies that takes advantage of this space data products, whether it's climate change, whether it's insurance, whether it's health industry. Or another way is, there's a lot of technology transfers, right, that could happen where startups could look at the technologies that were developed and work together to create another economy based on some innovations that has happened. So I feel like there's a lot of times we just kind of isolate ourselves space. Oh, that's not us. But in reality, it is everyone, either as a user or as a creator or as marketing or finance or art, anything. So I just want to clarify, like, space is really, it does require an integration of it all.
So if you think a little bit about the space economy now, you've got startups, public players, private players, all in the mix from different angles. Are what's the spirit like between those different entities? Is it one of collaboration? Is it one of cooperation? Is it competition? Is it a little bit of all of the above? What does that environment look like?
I don't think it's competition yet with traditional industries. I think the new startups still need the traditional industries for anything you do. So again, if I take the example of Intuitive Machines and Astrobiotic that was trying to land, they needed NASA as a sponsor or as a client, right? So there is that relationship. There's a strong relationship between the two. I think the opportunity is great in terms of private industries going there. Not only the fact that startups want to create something, but the fact that VCs want to fund it. So when VCs are ready to fund it, that means that you see that they are seeing some opportunities growing over there. I think from the traditional industry perspective, it might require a little bit of a relook at it. And to me, I think it's almost like maybe there's a need for a blue ocean strategy, kind of a mindset over there. I think government agencies are not out there to compete private industries. Their job is to help private industries. It has always been the case. NASA's always done one of a kind, create science and exploration, and then come up with technology innovations. Then a lot of time gets transferred off to, as an example, the CMOS detectors that's in our cameras was a innovation from JPL. I mean, the fact that we can have this great resolution pictures on our cameras was a technology transfer from space. And there are many other innovations like that, right? Memory foam mattresses and air purifiers and all of that stuff. So I think you will still see government agencies pursuing towards what the industry cannot afford to, but we still need to have that leap. But I think when it starts getting to in a recurring sense, you will probably see a lot more private industries coming in and government being a lot more using their services versus creating their services. So I think everyone is still trying to figure out where that'll go, but I don't think it's going to be one versus the other. It's going to be some sort of a collaboration. It will require traditional industries to think about it, saying, what should we be doing? Because some of the things we won't. And I actually have to be very appreciative of JPL, because they did actually combine one of the carbon plume missions, which is funded by a private foundation, with JPL's design experience with Planet's implementation. So you start seeing these things now, where there's a collaboration with the private funding, JPL as expert of design, and recurring production from commercial companies. So I think you'll start seeing a lot more models like this. What exactly it'll turn out to be is to be seen. But I would definitely say that we do need to kind of move towards a blue ocean strategy. Like, what should we be doing? And there's a lot of opportunities, a lot of innovation at NASA JPL. So how do we take advantage of that innovation?
So there's so many things you said that I want to double click on. So we'll take them in some sequence here. But you've mentioned blue ocean several times, right? And for the sake of our listeners and viewers, could you talk a little bit about what blue ocean strategy is? Like, define that a little bit so that everybody kind of understands the concept.
Okay, so blue ocean, and I need to give its parallel. Blue ocean, red ocean strategy is a assessment mindset framework process. I think if most of us are in the red ocean strategy, where we are doing competitive assessments and SWOTs and trying to figure out how can we compete So I would call that as a tactical strategy, right? Like trying to survive within your competition. Blue ocean strategy is understanding the landscape. So I wouldn't say you don't look at your competition, but it's really understanding your landscape of competition and see, can you jump out of there in a different area where there is where you're taking advantage of the innovation that you may have to offer in an area that the competitors are not there, lack of better word, or other players are not there is probably a better word. And what strengths do you have? What innovation can you bring so you create this brand new opportunities, right? I think for me, SpaceX is one of them, right? NASA was developing its launch vehicle the way it was. SpaceX went back, recognized that there was technology growth, did first principles, and built a reusable launch vehicle. And that eventually opened up industries that we're seeing right now over the last couple of years, where a lot more private companies are going up in space because the cost to launch has reduced quite a bit. Given said that, I won't say that it was just them. They did end up using a lot of resources from the traditional industries also, right? So there is a talent transfer that happened. But again, I think a private company taking that risk was a blue ocean strategy from my mindset, because they were not trying to do what has been done. They stepped away to see, and they weren't really trying to compete. They were really trying to innovate and open up new markets. So one of the things that I think is a blue ocean approach that EY is doing is through their Wave Space program, where they are bringing in luminaries from other fields, not their typical client support, into their clients to bring a different perspective in solving a problem. And so, as an example, there was one scenario where there was a need for, how do you address autonomous operation in a very human intense activity during COVID area, and wanted to go live. And so in that case, having a space mindset and a space application, I was kind of able to walk through them about, how do we operate in an autonomous way in a space environment? And what kind of things, what kind of risks do you need to think about? What kind of preparation, what kind of real-time operation scenarios do you need to train and plan for? So it's a perfect example. And I think EY seems to be in a right mindset and pathway to say, hey, not all the problems have to be solved with the same subject matter experts. Bringing SME subject matter experts from outside of the industries can give a different perspective to solve a problem, which is to some extent a blue ocean mindset.
See, you've made a couple references to sort of this tech transfer that can take place between, the Earth and space and the Earth. In your perspective, which industries on the ground do you think could actually be most transformed by what we learn in space in the future?
There's quite a few. In terms of applications, I think supply chain industry can be transformed if you're paying attention to space asset. I think I was reading something on climate change, and the fact that there is the relationship between climate change and certain industries. And there was this one scenario, the fact that there is ice melting happening on the northern side. That could potentially open up a supply chain route, right? Suddenly. I'm like, interesting. So I think, or the visibility that you get by the space monitoring and space data, that could transform the supply chain networks and bring efficiencies to your supply chains and maybe real-time transitions. I mean, you have this whole pirate scenario that's going on, right? That you have to reroute depending on what's going on. So I think definitely supply chain industry, but it's not limited to that. I think if private space stations come in, there is an opportunity for medical research in a microgravity environment. I think there's some benefit to the crystal structures that operate better in the microgravity environment, where the research can then translate into a better medical medicines down here on Earth. In fact, a couple of industries have already tried some of the microgravity. ISS, International Space Station, there has been some testing over there. 3D manufacturing, there's a big intent of trying 3D manufacturing also in space. There has been some tests already in space station. There is talks about, let's say, if we really do well in space with where we're going, then maybe there's some 3D manufacturing components that could happen for space assets. Agriculture, there's research again on the space station, but if you start having private space stations, there could be, an opportunity also in agriculture over there. So I don't think the opportunities are limited. I think we do need to think beyond what we think today to see how we can utilize it and take advantage of AI, ML, and computing and all of that. They all come together to make it happen.
So looking across that landscape of everything from supply chain to different forms of research, manufacturing, even tourism, which one personally excites you the most and why?
I would say definitely private space station is something I'm interested in because it opens up a lot more research capability. But beyond that, I think downstream data products for climate change, any kind of gap fillers for space assets for climate change. I was just listening to Simon Sinek yesterday. He was invited at JPL to speak yesterday. And one of the questions was, climate change, you have believers and non-believers. And he said, I think the messaging is it impacts the human race, right? So if we really think about that and take advantage of climate change data products and see how do we help ourselves, how do we monitor, how do we address what we need to do, there's an industry that can actually open that up in terms of the data products that come in from a lot of these Earth observing satellites. So those two, and then supply chain definitely, because I don't think we can survive without supply chain.
So we're going to pivot just a little bit. Hemali,
Okay.
when I was looking at your bio, you were a self-described multipotentialite, and I saw that term. I love that term, and what I'd like you to do is unpack that a little bit, explain to our viewers and our listeners, what that means to you.
Okay, so I did not create that term, so I'll kind of definitely share that. So I'll just tell you my history of how I got there. I love a lot of different things. I'm very curious about a lot of different things. I love challenges and solving challenging problems. As we talked about systems thinking and boundaryless and seamless and all of that together, I like to apply that to anything that draws my curiosity. When I started kind of creating a profile for myself, I had a hard time being in a certain lane. I was like, I don't know how do I explain my profile to anyone, because it could end up looking like hopscotching, which it isn't. It's really integrating a lot of experience and solving, I call it problem agnostic. I would love to apply it to any problem. And then somehow I came across this TEDx, and I think her name was Emily, and it was said multipotential. I'm like, okay, let me look at what she's saying. And every word she said, I'm like, oh, I feel like I'm that. I have a lot of interest. I have a lot of curiosity. I like to do a lot of different things, sometimes at the same time, like, NASA JPL and Warehouse Exchange, for example, or owning a hospitality company and stuff like that. So I love to do a lot of things. I'm interested in consciousness and collective intelligence and everything. So there's no limit to that, but it felt like I could not define myself. And when I came across to that term, multipotentialite, I felt like it helped define me a little bit more better. It gave a little more better identity for me, that it's someone who really is curious about a lot and would like to apply themselves to a lot of different problems rather than being in a single lane.
So how do you see that contributing to your ability and the ability of others when it comes to being able to drive innovation, to create innovation?
I think what that does is that because you have this experience, a varied experience, from each experience you learn something. And as you increase and expand that area of your experience, now suddenly you, in your mindset, you can probably create analogies, you can create patterns, and you can start applying those analogies and patterns to whatever else may be outside, right? So I feel like it has made it much more interesting for me because I can apply that mindset to just about any industry or any problem. Just within JPL NASA, if I just stick to that, my background was communications. From there, I went to a startup that was doing GPS for a chip on the ground. And then I came back and I did science instruments involving detectors and infrared detectors. And now I'm doing institutional relationship that combines both technical as well as programmatic, as well as approach and processes and enterprise for IT. So it wasn't as much of a problem, but as much of a curiosity, the challenge of the problem, and how do I apply my experience and what patterns can I create. And at the end of the day, I really do believe everything is integrated. And the more we see in terms of the integrated fashion, the more we can help each other to solve the problems in a much more better and efficient ways.
Coming at it from a multi-potentialite viewpoint, how does that impact your perspective, your approach to collaboration?
Collaboration is very, very important. We don't live in an isolated mode. When we're working, whether you're a 2 or 3 people startup or 5,000 people company or more, anything that we do is a collaboration, right? So I think to me, collaboration does not mean that we need everybody's vote. But collaboration is really understanding the problem and its silos and seeing where the gaps are and communicating the gaps in a team fashion to resolve, and in a mathematical term, I'll say create a Venn diagram of it, right? Like see where all the circles meet. We all have our individual whatever desires or expectations, but when we come together, we'll find that sweet spot in there. To me, that's collaboration. And through that collaboration, we get that consensus from the appropriate stakeholders and move forward, because it's not just about agreement, but it's also making sure stakeholders are included in there so that you can actually get to the success of what you're trying to solve.
Building on the theme of collaboration a little bit, I know you've taken a real commitment to diversity in your work, and really tried to bring a wider range of people and students into science fields through STEM programs. Could you expand a little bit on the work that you're doing there?
Yeah, so that one is a little bit multifaceted. So as a AIAA, I have a couple of different roles in AIAA. I'm definitely, the economics committee chair is one of it, but I also am chair of the local region. And in that local region, we try to do a lot of activities that brings in young professionals, that brings in high school students. In fact, we just participated in a high school student fair to bring awareness of the STEM industries and aerospace industries, and bring in. I was in fact mentoring one of the high school students who graduated last year and was awarded by AIAA as she transitioned to her undergrad. And she reached out to me, so I'm mentoring her for her path and whatever questions she may have. So all is this, and then besides that, at USC Viterbi, I've kind of supported as an advisory for their startup roles and mentors over there. So it's a combination of different things that I'm trying to help out wherever I can. It's a paid forward mindset.
So in closing, if there was one piece of advice you would give to students, or I'm not sure how many of our listeners and viewers are students, so maybe the parents of students, right, around the importance of STEM education, what would you like to tell people? What would you like them to take away?
I think in terms of STEM education, I think speaking to the parents of the students, I think exposure, a lot more experimental exposure to STEM. I think sometimes the education is a little bit more rigid about solving math problems. But if we solve math problems but don't know how to apply it, it makes it a little bit hard. But as soon as you open up the applicability of STEM, the curiosity on its own will take the students to where they want to go. So exposure is an important thing. Analytical skill set that comes out of it. I think STEM is one area. Actually, I should say STEAM. Nowadays, there's a lot more interest in STEAM. The analytical exposure from STEM is very, very important because it allows us to really logically think about anything rather than accepting it blindly. And I added a part of the STEAM is because arts is also as important as STEM because it enhances your creativity. When you combine your analytical mindset with your creativity, suddenly you combine your left and your right hemispheres, and you get to see problems in a lot more integrated fashion. And like I said, I'm all about integrated view. I'm all about combining together, coming together, so we solve a lot more bigger problems or come up with bigger solutions in an integrated way. We're including everyone and also thinking it from a different perspectives.
So Hemali, this has been a fascinating discussion. And in closing today, I would just like to ask, is there any guidance, is there any advice you would like to leave our listeners and viewers with today?
Thanks, Brent. One thing I would like to leave with is to always have an ability to think in terms of systems thinking. And when I say systems thinking, I'm not thinking in terms of compliances, but in terms of really taking the opportunity to ask questions, why or how, is it relevant or not? And I think applying that with STEM and STEAM, STEM being the analytical mindset and STEAM being the A part of the arts and creativity, I think ability to combine the two so that we're using a left and right brain both at the same time, I think will give us a better way to see things in an integrated fashion. And I think systems thinking is really the way to go. It can apply to any kinds of problem set, any kind of solutions at any level by anyone. And I think it's needed not to think in terms of innovation and also to execute on our innovations and our strategies.
That's great. I can't think of a better note to end today's discussion on. Hemali, thank you again for your time. I really, really appreciate your time today and your perspective, and really just want to wish you the best in all of your endeavors.
Thank you so much, Brent. It was really great talking to you today. I truly enjoyed our conversations.
The Decoding Innovation podcast series is a limited production of the EY Nottingham Spurk Innovation Hub based in Cleveland, Ohio. For more information, visit our website at ey.com/decodinginnovation. If you enjoyed this podcast, please subscribe, leave a review wherever you get your podcasts, and be sure to spread the word.